Hey guys, so today we're going to solve the problem flood fill on Leetcode. So the question says given an image is represented by an m cross n integer grid image where image ij represents the pixel value of the image. You're also given three integers sr, sc and new color. You should perform a flood fill on the image starting from the pixel image sr, sc. To perform a flood fill, consider the starting pixel plus any pixels connected 4 directionally to the starting pixel of the same color as the starting pixel, plus any pixel connected 4 directionally to those pixels, also with the same color, and so on. Replace the color of all the aforementioned pixels with the new color, and return the modified image after performing the flood fill. Okay, so let's take this example and let's start. Okay, so yes, so this is the question, and yeah, so what the question says is that we're given a starting point SR and SC. So for an example, in this question, the starting point is 1 1. So this point will be our starting point, and what we have to do, so the value present at that point needs to be converted to the new color value. Okay, so here we have 1. Okay, and 1 will be changed to 2. Okay, the new color value, and we need to check if there are any values connected to it 4 directionally, like up, down, left and right, like this up, this down, this left, this right, and we need to convert those values also to a 2 if there. So like if this is a 1 and those 4 values have also a 1, any one of those 4 values or all of those 4 values have 1 in their places, like this has a 1, this has a 1, this has a 0 and this has a 0, but if these two have a 1 and this was also previously 1, so this will be converted to a 2. Okay, so we can go from either up, either down, either left or right. So let's go up. When we go up, we'll check if this is equal to 1 or not. If it's equal to 1, we'll change this to a 2. Okay, now when we change this to a 2, we'll check for this one's up, down, left and right. Okay, now when we check for this one's up, down, left and right, we find that we can go like, we can't go up, we already came from down, we can't go down back, we can go left. Okay, now when we go left, we can change this value to a 2. Now when we change this value to a 2, okay, now this is changed. Now we can check for this value, this one's up, down, left and right. We can't go up, we can't go left, we can't go right, but we can go down, and we also have a 1 present, so we can change this 1 to a 2, and we can check for this one's up, down, left and right. Okay, now when we check for this one's up, down, left and right, we can't go up, down or up, left or right, but we can go down, and when we go down, we can change this to a 2. Okay, now when we reach this 2, now you can't go up, down, left or right or any other spot. This is already completed. Okay, for this one, what we'll do is we'll go back to this 2. We'll check if we can go up, down, left or right or any place else. We can't. We go back to this 2 from where we came. We check if we can go up, down, left or right. We can't. We go back to this 2. Now in this 2, what we had previously checked was if it could go up, if it could go down, or if it could go left. Okay, and because it went left, we went over here and changed these values. Okay, but now when we came back, it can also go right, correct. Now if it can go right, we go to this one and we change it to a 2. Okay, now when we change this to a 2, we'll check for this one's up, down, left and right. Okay, and when we check for this one's up, down, left and right, we see that we can't go down because there's a 0 present over here. We already came from left. We can't go right, we can't go up. Okay, we go back to this 2. We go back. Now since we check for this 2 again, we already checked for down, we already checked for up, we went left already and we went right. Now we can't do anything. We go back to this 2 and we check for left, right, up and down again. We went up previously. Okay, now we check for down, we check for left and we check for right. We can't go anywhere else, and then we just return the new array which we get. And this one which over here, it doesn't get changed because it doesn't get accessed through any value, because there isn't any 1 connected to it, so through which it could be accessed. So it remains as a 1, and in the end we just return this array as the output. Okay, now if you check over here, we have a 222, a 222, 220, a 220 and a 201. Okay, it's the same, and this is basically the output of the question. Now what's happening over here is we're actually just performing a DFS from the position we're given in the question. So we're given SR and SC as 1. We go to the spot and we start performing a DFS from this point 4 directionally, and once we find any spot as a 1, we go to that point and we start performing DFS on that point 4 directionally, and we go do that until all the ones are accessed, all the reachable ones are accessed. Okay, so this is the whole question, guys, and let's just code this out. Okay, so yeah, so we have color equal to image SR SC. Okay, so the color will basically be this one, and we'll access it using image SR and SC. And just one thing to note over here, guys, so the SR and SC point which we are given, like over here, will go to this one, okay? But if it were a 2 over here, so then 2 would have been the color, and we would have checked for each and every 2. If this would have been a 2, we would have only then changed it to the new color value. If it would have been 1, we would have changed that 2 to a 1. Okay, so this SR and SC basically tells us the starting point as well as the color which needs to be changed to the new color. Okay, so yeah, now let's just check if the color is equal to the new color, sorry, COLOR. If this is true, we'll just return the current image, whatever we have, because if the color is equal to the new color, we don't need to perform anything, and the output will be the same. Okay, so now we have to perform a DFS image SR and SC, image SR SC is equal to new color. We change the value of the point, very first point. So like we have image SR and SC equal to this point. We first change this point's value equal to 2, and then we access it 4 directionally. We go to its points 4 directionally. So for doing that, we just create a list, and what we'll do is we'll do SR minus 1 comma SC. We'll do SR plus 1 comma SC. Then we'll do SR comma SC plus 1, SC minus 1 or plus 1, any one would be fine, and SR comma SC minus 1. Okay, now what this list is basically just checking it 4 directionally. Can it go up, can it go down, can it go left, and can it go right, and we'll be checking if those values are 1 or not. So for row comma column call in LST, if row is greater than or equal to 0 and column or call is greater than or equal to 0 and row is less than length of image and call is less than length of image and image of row and call is equal to color, then we'll perform a DFS on that point. So it will be image comma row comma call, and in the end let's just call this DFS to image SR SC and return image. So let's run the code. Yeah, and submitting it. Okay, we have an issue. Okay, so this is image of 0, right? We're checking the number of columns. Let's submit it again. Yeah, it's accepted. Okay, let's do a dry run one more time, guys, just to solidify what we understood over here. So what we're doing is we have a question like this, Okay, and what the question says is we're making the color equal to image of SR and SC. So now the color variable will be equal to 1 because SR and SC is 1 1. So this point is equal to 1, that's why color is equal to 1. Now if color is equal to new color, then we'll just return the image, but it's not the same because the new color is 2. Okay, now we start performing the DFS. We just call this function over here DFS with image SR and SC. Now we firstly make the image SR and SC equal to new color, so this will be equal to 2 now. Okay, now we make a list of all the places, like if it can go up, if it can go down, if it can go left, and if it can go right. Now to access these elements, SR minus 1 and SR plus 1, SR, we call row, and to access these elements SC plus 1, SC minus 1, we call column. Now if row is greater than equal to 0 and column is greater than equal to 0, which means they can't be less than these values, like these are 0, 1 and 2. It can't be minus 1 or something like that. It should be 0 or greater than 0, and row is less than length of image, and which means that the number of rows over here are 3, so the rows should be less than number of image, like it should be 2 less than 3, which is 2, and column is less than image of 0. So an image of 0 has 3 elements inside it, so the number of columns should also be less than 3, which is at least 2. Okay, and if image of row comma column is equal to 0, equal to color, which is 1, then perform a DFS on that. Okay, so basically what we did before, SR minus 1 and SC. So what is SR minus 1? We go over here. So SR minus 1, we go over here, and SC is the same, and we check for this value. So it satisfies all these conditions. So we just make this equal to a 2, and we go over here. We check for its up. We can't go up. We go down. It's not equal to 1. It's equal to 2. So we can't go over here again. Now we go for its left, and we go for its right. Now let's go for its right. So this is changed to a 2. Okay. Now when it's changed to a 2, we come back. Okay. We come back, and then we go to this position, because this is the only one left. And we go over here, then we go over here, then we go over here. Now this is full completed. We can't go up, down, left or right. We go back up. Similarly, it's completed. We can't go up, down, left or right. We go back here. Again, it's completed. We go here. It's completed. We go here. And this was the start, and this was the start of it, and the very first position. And we check for the rest of we check for the remaining elements. The up was the very first thing it did. I will check for down, left and right. It can't go any place else because there's no one present except for this one, but it can't be accessed because the neighboring elements of it aren't 1. So those can't be accessed. That's why this can't be accessed. This one can't be accessed, and we just return this image as the answer. Okay guys, that's all for today's video. And if you like the video, please do like, share and subscribe, and I'll see you guys in the next video. Thanks.